right, well, welcome everybody. Thank you for all joining the webinar today. Today's webinar is going to be on laser scanning for collision reconstruction, and I think this is a relatively important area if you think about the contribution that laser scanning and even total station mapping has had with accident reconstruction and vice versa. A lot of accident reconstructionists have taken on the taken the total station and now laser scanning under their wing as a documentation tool. So, as time moves forward here, I think we're going to see more and more people with laser scanners and using them for collision investigations and for the documentation of collisions and such. So today we have three speakers. We're going to start off with Dave Foster. He's the Senior Collision Investigator for the North Yorkshire Police. He heads up the Forensic Collision Investigation Unit, and he's been involved for at least 15 years with this type of work. And I had the opportunity to meet Dave at SPAR just over a year ago, so that would have been November the year before. And I think partly it was his presentation there that prompted me to ask him to assist us. Dave is very involved with laser scanning, and he really promotes the technology. So, David, thank you. We're very fortunate to have you here. Our second speaker is Bobby Jones, and he's an ACTAR accredited reconstructionist. He has over 30 years of experience in crash reconstruction, and he's a certified instructor using the laser scanner total stations and also many CAD software programs as well. And I've also had the opportunity to meet Bobby before, and he's had some great presentations, so we're very grateful for him being here as well. And he's actually sitting right beside me, so I'm speaking on the headset, so his mic is muted right now. Finally, we also have David Dustin, who's the president of Dustin Productions. Dave has been involved in the IAFSM. He has been working on crime and accident reconstruction, doing visualizations, laser scanning for several years now as well. And so Dave is going to take up the tail end of this presentation, looking at some other things with accident reconstruction. So on that note, I'd like to begin with Mr. Dave Foster. And Dave, take it away. Thank you.
Well, thank you very much for the invitation. As I say, we met with Eugene, November 2012, I think it would be, at the start of 2012, where we had not long in the UK taken on board the development of laser scanning as part of a method of data capture at collision scenes, and I have to say it's been very, very good how it's so I'm probably going to be producing this as a PowerPoint, which is the easiest way. Unfortunately, one or two of the UK contingent will know some of our ability to operate from our offices isn't as good as it perhaps might be. Obviously, this is the sort of scenario that almost collision investigators in the UK are far too familiar with. And as Eugene alluded to before, the earlier way of recording this data was superseded with total stations and a GPS, which is a great leap forward. Certainly forward than that idea of 3D data capture, which did bring us a small smile into the office. But it's probably a good idea to actually have a little run through of what we were looking to do with the laser scanning. There were certain criteria, certainly in the UK, when the funding for such instruments was given to us, restricted in certain areas. So essentially phase-based instruments were eliminated from the scope of the purchase and the funding availability. That said, of course, there were still some fantastic instruments out on the market. There were a number of considerations to undergo before making a choice when spending public money. And a number of these was down to some of the more simplest ideas which the sales reps from various companies wouldn't have been able to get a grip on. Things like just how easy is it actually to set up. As you know, we're fairly time constrained at these sorts of scenes, so we need to be able to get set up and capturing that data pretty much as soon as we can and as fast as we can. So those were some of the initial issues that we're looking at, together with what the speed of the scanning was, and also some of the backup aspects, such as how effective was the download to store the data, the actual range of the instrument, accuracy versus precision. We don't need to be so precise in the world, but when we are scanning each, if it says it's a meter, it needs to be a meter. Other considerations that I was looking at, bearing in mind this sort of terrain that we work in is good weather resistance. We can work from minus 10 to plus 30. I know in some parts of the world that's nothing, but in certain parts of Yorkshire we can get that during one day. So IP64 capability was also a major consideration, together with the support. So in the end, as you can see in front of you there, North Yorkshire, we chose the Regal VZ400, and to date I've been fully vindicated in the decision that we've made. Nationally, 2/3 of all the police forces that went for this laser scanner ended up picking the VZ400, and I'm sure they're probably enjoying the learning curve that has been steep in the last 2.5 years since we've got it. Additionally, we're also looking at the software package that comes with it and how that develops. So obviously some of the criteria that came as on the back of that was improvements in clear-up time. We're talking millions of pounds, millions of dollars certainly for 2 and 3 lane motorway closures per hour, and clearly the faster we were recording that the better. And there was also the objective data gathering that the scanner provides us. It records what it sees. There's no picking and choosing. Not that I'm saying that we do, but it certainly eliminates any suspicion of that. So going on to about the speed of what the scanner can and can't do. For those of you who don't know, the Regal one that operates at 122,000 points per second. Although it will actually record more than that because it has onboard waveform analysis, so it can, in theory, record an unlimited amount of returns. Doesn't have a dome, 360 dome capability, but in the sphere that we tend to work in, I've never yet found that a hindrance. So this is what we're using. You've seen the photographs. You'll also notice on the invitation to this seminar, this webinar I should say, the photograph on the left-hand side, and we'll be coming back onto that in a minute. For those of you with the Anoraks, the white car is an Isuzu Piazza Turbo, and at that time, about 30 seconds before the crash that you see on the left-hand side, that was one of 7 that was left in the UK. Unfortunately, now we're only 1 of 6. But what we can produce is in relatively quick time is plots. Now this is very important for briefings and such like that occur straight after in a day or two following serious incidents, so people are aware of what it is that we're trying to talk about. And it's similar again on the right hand side. The picture there is taken in relatively fast melting snow, so we had to have a rapid data capture method in order to record the marks that were left by the vehicle, and we'll come on to both of these as my little chart is. So we're looking at producing a plot, as I say, in relatively quick time. This is nothing too fancy. This is if you might want to think of this as a very early stage in the briefing context. So we can produce fast plots from this, the scan data, as well as video fly-throughs relatively quickly. The software that we use as partner software with RISE, with the VZ400 is RISE Scan Pro, and for production of videos we're using Point Tools. Other software packages are available, of course. I talk about the objectivity of the, and this is the same one that we were talking about with the snow melting the marks away. But what we found out 3 days later is one of the houses nearby actually had a small CCTV camera fitted, and it also was fitted with audio. I'm not going to show you that on here because it's reasonably horrific, but what we're able to show is, as well as the layout of the scene, the scanner picked up the exact position of the CCTV point here. As you can see, I'm highlighting with the cursor. And from that, we're able to pick up 2 reference points, highlighted just here, and in that area there, for which both the deceased, who was a pedestrian on the pavement, which is in that area there, was walking, and is walking from left to right as we're looking, as was the car that was travelling basically from the bottom left towards the top right, the line of the road. And from that data, we're able to work out a speed, which is a relatively simple calculation. This one is just a time and distance calculation, but it's supported analysis from the CCTV frame rates, etc. This is a 30 miles an hour speed limit road, and giving the defendant as much benefit of the doubt as possible, we were able to ascertain that he was travelling at a minimum of 73 miles per hour. I mean, that is pretty consistent with all the witness accounts as well. Describe this as a motorway speed collision. So that's the sort of scenery that we're looking at there, and the end shot as well. These are all key points that come out. The deceased ended up at this point here. He was carried on the bonnet of that's a Range Rover Sport, as you can see. That impact there is the pedestrian. We were able to scan in the vehicle in more detail 3 or 4 days later after we had finished with the forensic aspects, and produced a really detailed scan of the damage to the vehicle, which assisted in pinpointing exactly where the damage and the impact had occurred. We talk about producing fast outputs. Hopefully this video will be showing you now. I'll give you a little bit of an insight of what produced in relatively quick time, but with the amount of data that's actually capturing. So we're looking at 4 scans in total there, 19 minutes, that's from setting up to having the information downloaded onto the memory stick. And because of the amount of data that there was in the area, we had around about 30 minutes of processing time, and then 30 minutes to convert that to video, again to produce, so people can actually ascertain what has been the likely layout of the area. Subsequent to that, of course, once we start getting into a little bit more of the information, the data that is captured allows us to carry out much more detailed analysis of the scene and the sites, lines that are available, any obstruction. Here we have the crossroads and crossroads junctions. The main road is the one that runs horizontally, so it's broadly from right to left. And the side roads is running vertically from the bottom to the top, with the offending driver coming from the bottom. And this is the view that a driver will get, the offending driver, as approaching itself. One of the main issues with this is the fact that the road actually drops down to the giveaway, and or the stop sign, when the stop line is actually, although it looks like it should be over here, it's actually hidden out of view in this area here. It creates quite a problem. As we can see, good data recording of the actual scene itself, together with the markings, which are in a very poor state. The stop sign is actually angled here and out of the way. Well, this is the view that the driver's getting to the right, which is fairly limited, and you can understand why the stop sign came to be in the way that why it was put there in the first place. Similarly, the information recorded lets us look at obviously sight lines, obstructions. Now we're looking at scene information, so we're looking at slopes, grades, camber measurements, and such like. And that hopefully illustrates the full 3D capability of the instruments and what we're actually being able to extract from the data information. We've got a 1 in 9 slope, which is roughly about 6 degrees or so, but certainly enough to contribute to this obvious toppling over that and some meshing around. Hopefully this is going back to some important work here now. So, two vehicles, I say this is a T-bone style collision with our Isuzu Piazza, and that's a Nissan Qashqai, which is like an SUV, on the right hand side. So from this we should be able to look at developing some impact alignments and crush analysis, and we visualise this impact. Isuzu died around about 3 months after the collision from complications, but the pathologist was particularly interested in the images from the scan actually, because he was able to pinpoint key injuries on the deceased and eliminate them from the other events that have occurred both before and after his hospitalisation, which you can probably gather from that is it sounds like, and it will be a complex investigation forthcoming. But those are a great little example of actually piecing the damage together. Similarly, we can actually reconstruct the entire into its virtual environment. So this is the post-impact position of both vehicles. You can see the silver car and the blue car at the bottom here, and then amongst all of this lot here, the large amount of impact debris, the actual point of impact occurring roughly there from this slide. We'll have a look at what we can do with this data, having extracted the vehicles. We can then put them back onto the collision mark, relative points of impact together. So wholly on the wrong side of the road, for a reason that has never been truly answered. Nothing mechanical, but it is a clear illustration of what we're able to do to both analyse and illustrate the pages and pages of reports that we tend to produce, and ultimately we can just say, here, have a look at this. This is what I'm telling you. The chap's on the wrong side of the road. I'll just have a flick over here because this is not working before. It says hopefully. There we are. So going back to our Isuzu Piazza Turbo to produce the 2D line drawings, and this is extracted from that information. If you look at the scene data here, the scene capture, that was around about 45 minutes of surveying with eight positions. And then around about an hour in the office extracting the line data after registered all the scans. You'll be looking at least an hour and a half to 2 hours of walking around that scene to capture the amount of data that is necessary with either GPS or TVS. Just so we explain what's happening here, I'll move this over to the zoomed in area. The Isuzu has been travelling along this line here and wanting to turn left onto the dual carriageway, and the red car's been travelling from right to left. Unfortunately, the Isuzu has failed to take into account all of these no right turn, no right turn, no right turn, no right turn signs, and has tried to cross over onto the other side of the A64, despite everything else, pushing it to the left. Collision occurred in that area there. Very unfortunate, but the amount of data captured by the scanner, together with the subsequent analysis that we're able to create, is really good. So we've got some fantastic instrumentation, but one of the slowest points, or one of the biggest blockers for people using it, is the amount of time spent in the back office. It's all right spending next to no time out in the scene getting data capture, but if people are then start for 3 or 4 or 5 hours, whatever it is, registering a number of scans together, any time savings are negated at a personal level. So what we're able to do is, together with Regal, and many thanks to Amanda Fowler for this invitation at Regal, we were able to develop a true automatic and targetless registration package called RISOL, which is part of the RISCAN family of software. And I'm not going to sell it to you as a salesman, but I can sell it to you as a practitioner. It's a piece of kit that really works. We've been able to utilise all the data that's on board the scanner so that it actually registers automatically within RISOL. Being produced for non-surveyors like myself to actually produce some really good registered scan, coloured within 1 minute per scan position, set for colouring, and produced 2D scale plans on PDF. So we're very pleased with how that's gone. It's really made the job that much easier. With a bit of luck, it should hopefully boost up the time that we can spend doing the other parts of our work, which is the analysis and the reconstruction. We're very impressed as well with the amount of detail that is captured. There's a little entrance lodge to our piece of quarters out in the sticks. Again, that's on about 6 scan positions. For those with the Regal background, this is scanned originally at panel 60, and then on each corner put in a detailed window at panel 30 setting to add in the detail for the buildings. It's come out pretty well. I'm very pleased with that. But in terms of time and amount of detail, again, it's fantastic. And you can see how we can extrapolate that sort of usage into crime scenes. This is a practice scene, if you like, just to illustrate what we can do with it. That gives you some pretty good pointers as to what we're doing in the UK. I'll probably throw the floor open now for any questions if anybody wants to come back to me.
All attendees are muted and may unmute themselves by pressing *6.
So hopefully if anyone's got any questions on that, or if, Eugene, can you quickly move back up?
Okay, so one question came in here. It says, how does the target's registration work if there are no surrounding buildings surfaces to align? Do you see that one, Dave?
Yeah, so yeah, I've just seen that pop up now on the screen. I have sat down with an AMDA, and he has explained to it how it all happens. Some of it did go a little bit above the head, but essentially what it works on with the Regal VZ400 has its own L1 GPS locator on the top, which gives it its own location to roughly within 6 meters on the world, which is not too bad. But taken together with the same data that each scan position is recording, together looking at all the inclination sensor readings and such like, that then gives plenty of data to provide a course registration. The software has been developed somewhat from RISCAN in the way that it actually develops the registration processing. So it will look at other aspects such as the alignment of various planes that it looks to calculate. So I have tried it where there are no surrounding buildings and surfaces to align, and yeah, it does work. It's one of those bits of software that it does do what it says it does. Can't guarantee 100%, but when we're talking high, in excess of 95% of the times, it will register without having surrounding buildings and those sorts of surfaces that you'd normally expect. typical registration accuracy, we're probably sub 10 millimeters. The Regal user conference in June, we were talking around about 3.5 millimeters, which is pretty good. Personally, I've not run into any problems presenting scan data in court. I'm sure there'll be something that comes up, but in the same way as GPS, TPS has been challenged and eventually acknowledged as being accurate, then I'm sure the same will apply to laser scanning. It will have to be a challenge, I'm sure, but when it's fully demonstrated and explained together with the accuracies, I don't see ultimately that it will not, or it will be creating any issues at all. I hope that helps then.
Okay, if you've got any other questions, please just type them in the chat bar down there. Otherwise, Bobby Jones was scheduled to be our next presenter, and apparently he is with Eugene, and Eugene is having some audio issues. So I will try to get him reconnected right now. So if you'll just give us a minute or two, we'll see what we can do.
If there's any further questions you want to about the legal instrument, then feel free to ask me whilst we're waiting. I've been asked to prove the accuracy of the scan data. Not formally, but we tend to supply a report with the data that occurs within the documentation that we send off to CPS. I don't know quite how it works in other countries, but here we basically say everything that we've ever done is bundled into the file. Some of it remains unused, some of it's used. We tend to, in the unused bundle, that documentation is available should anyone want to query it. So Eugene's screen flash up there in a minute.
Okay, so they're signing back in, so we'll give them another minute or so here. Sorry about that, everyone.
Just to go back to Dominic's question about the target's registration, I should really get hold of Fernando and ask him to provide a little how it actually happened type sheet, because it's a lot of it went over my head. It was interesting, but some of it I had to sit down and chew and think about how it was doing.
Hey Dave, can you hear me at the moment?
I can actually, yeah.
Oh, finally back here again. Okay.
Yeah.
So is this a good time to switch over to Bobby then?
I'm finished, mate. If you want to move on.
Okay, so I'll get Bobby set up here. I don't know if you can see this part. Let's see here. It's thinking here. Just a minute here, I'm just going to have to restart something here.
Hello, everyone. Dave, that was a great presentation.
Thanks very much, Bobby. I'm looking forward to this.
Well, I'm looking forward to meeting everybody one day that's attending this webinar, and I appreciate the opportunity to do this. Thank you very much, Eugene. Today, what I'm going to talk to you about is how that I use laser scanning in crash reconstruction. Eugene told you I I'm a private consultant. I'm also a deputy with the Knox County Sheriff's Office in Knoxville, Tennessee. So I use this both on scene and post-crash data analysis. Now I'm taking some slides from the Federal Users Conference that I did a few months ago, and I'm going to kind of skip some of the slides so I don't bore you too much. But just to start out, to tell you that laser scanning is appropriate, as we know, for both crime and crash scenes. And we've seen laser scanning used at crime scenes quite often, but it's just now seeming to knock on the door of crash reconstruction. And by that I mean for the last probably 6 years or so, we've seen it coming into crash reconstruction. The difference, at least that I note, is that crime scenes, we scan smaller areas, we have static environments, we typically have controlled access, so we have a lot more control on how we're going to handle recreating a crime scene through photography and through scanning. Unlike crime scenes, however, crash scenes differ than the fact that they are larger, and they often require a lot more thought, a lot faster pace, because they are uncontrolled. We have live traffic, both vehicular and pedestrian. You have a dynamic surrounding. In other words, often we find on some of our larger highways particularly that we'll be rerouting traffic and other lanes rather than shutting an entire roadway down. So the scene is constantly changing. So in this example, what you'll see in this crash scene, if you'll notice the background, you see people walking through the scene. And this is the dynamic part of crash scene scanning that becomes an issue, but is so important for us to get started immediately when we get on a scene to capture the data. Because scanning crash scenes, for the most part, is in its infancy, and because of the rapid pace that the scene changes, efficiency is absolutely the key in preserving the evidence. And as Dave was talking about in his presentation, where he was capturing the tire marks in the snow, I can certainly relate to that because as these scenes change so fast, reliability of our scans certainly has to be proven, and as we move forward, all of us together will step through the paces and develop better protocols and better methodologies. We're also going to be facing challenges on accuracy, but there we will insert standards, checks, and balances, just like we have done with total station data in the past. From there, we'll have generalized protocols that typically will be adopted throughout the communities, and that's how we will survive these attacks on this new technology. I often talk about laser scanning and when to use it. And I recommend that we use laser scanning anytime you have an opportunity. If you have an opportunity to take out a camera and take a picture, likely you have an opportunity to get the scanner out of the car and take a scan. These scans are fast, they're easy, they're quick, simple, so there's really no excuse for us not to use them. And by using these scanners on these less important crashes, it gives us an opportunity to practice, which in turn makes us efficient. So when we have the big crime scene or the big crash scene of the utmost importance, for whatever reason that is, whatever catastrophe, we're ready to handle that. So we talk about, when do you start scanning? And that's as soon as possible after you arrive. At least that's our methodology. When we stop at a crash scene, our vehicle physically stops moving. The first thing that I do is to put on a vest. The next thing is to turn on the scanner. Even before I'm walking the scene to figure out where I'm going to place the scanner. The reason is that this evidence is so dynamic. It changes so constantly, and it's changing all the time. The evolution of these scenes and the evidence demands that you begin the data collection as soon as possible, else you run the risk of losing the data. The setup, we don't waste a whole lot of time getting set up. As soon as that scanner is ready to go, as soon as we can get some data entered in, we start scanning. We don't necessarily worry about targets, placement of spheres, or anything else when we start scanning. If we can implement that, that's great, but it's not critical. Getting started, however, is absolutely critical. And we recommend to guys not to overthink the scan. Certainly there's an amount of planning that you can have after you get started, but just getting started seems to be the hurdle with most scanning tasks anyway. We found that too much planning leads to time and data loss. Safety. So we say the number one priority for you and the equipment is safety. Set up in a safe location. Make sure your scanner is safe just in case you have to walk away from it. We recommend maybe draping a vest over the scanner tripod, or set up cones around your scanner, and establish a work area that is clearly visible so that people won't accidentally run over your scanner or run over you while you're scanning. Keep people away from the work zone. We try to establish these work zones and get people away from that scanner. It's so intriguing. People want to look at it. They want to know what it does. We find that we often find a face in a photograph that was unplanned, or someone in the scan that was unplanned, just because their curiosity took over and they would stand right in a direct line of fire of the scanner. So we want to establish a safety zone for a lot of reasons, but it helps keep people out of our scan. So we want to get you set up immediately upon your arrival. Turn the scanner on, locate a safe position for the scanner, set up the tripod, mount the scanner, create a scan file. Naming conventions might include the date and the time. Reset your sensors if time permits and hit the scan button. Get started. That's what we're trying to get you to do. So we don't want you to waste time. We want you to stay busy and focused on the task that you have at hand. Be prepared to move the scanner to the next location. Think about where you're going to put the scanner at your next location if you have the opportunity and time to do so. Be aware of where the scanner's progress is. And by that, I mean avoid downtime. Don't waste time talking and planning other activities when your focus should be on scanning and collecting data. Your scanner should always be working when it's on the scene. If it's not working, you're certainly wasting time, and you're taking you're losing the opportunity to capture critical data. Anytime you can, use targets, whether it's spheres or other types of targets. We certainly recommend that, but it's not often possible to do that. Make sure that when you place your spheres and your targets out, that they're in controlled areas where people won't move them. Make sure that they're visible from multiple locations, and make sure your spacing is considered. Because these scanners can take 360-degree images, it makes for a nice pan around. Often we find ourselves scanning at night and the photos don't come out so well. So we consider photos as a luxury, and we only scan with photos when lighting is adequate to do so. So in low light scanning, because these scanners see very well, we use grayscale, and it saves a tremendous amount of time for nighttime scans. Excuse me. So as I'm trying to get to a diagram here so you can see the difference between a color scan at night versus a grayscale scan. So by changing and turning, or simply turning off the color, we're collecting so much better data. We're able to see things in the grayscale that we could never see in the color. So we try to avoid the color at night when at all possible. This is an example of a room completely dark with no color, but you can see the details of most everything that you would need. Complement this with a nice set of digital photographs from flash photography, and your crime scene is likely going to be pretty much complete. So when you're scanning, you're thinking about, well, what methods do I need to use? And there's lots of ideas, and there's a lot of people that know much more about this and better than I am. But what I've found is that I try to establish what is the purpose of my scan. Most of the time, it's to create a line drawing. So basically, I've got a total station that's on steroids, that's collecting millions of points rather than a few hundred. So I might need to do a simple speed analysis. So all I would need may be distances that a vehicle travels over a particular surface. I may need a detailed analysis. Maybe I have rotational issues or crush that I need to consider, or time and distance. I might have a visibility study that may require me to shoot a few more scans so I can collect more data on the roadway surface. We try to be as efficient as we can and collect most everything that we can from one single position. And this is particularly important when you have evidence that's changing, when you have smaller evidence that may be blowing around, or weather is not cooperating. The advantages of this is it's quick data collection. You avoid registration errors, and likely you will be able to see most everything you need from one position. Now, often we will take advantage of multiple positions when the evidence can't be properly documented from any one single position. So the techniques that we use: rectangle, a circular technique, zigzag technique, and path of travel, depending on what we're trying to document. Vehicle scans. The method that you'll use when you scan a vehicle, depending on what it is you're trying to accomplish. So for example, if you're modeling, you're going to take a lot more scans. If you're animating, more scans so you can create a better looking model. But if all you need is crush analysis, you may be able to get by with a single position scan. If you're calculating momentum, maybe the same thing. Maybe a single position scan so you can document the damaged areas, if that permits. Single position scans offer, again, efficiency, and you avoid registration errors. We started using the Faro scanner a lot more on vehicle interiors to capture information that we've typically overlooked or never really been able to document well in the past. This is helpful in occupant kinematics, documenting apartment contiguity, looking at seat belts, and all this can be done typically from a single position. Exemplar comparison, scanning damaged vehicles, scanning an exemplar vehicle, and making a direct comparison like we've never been able to before. Pedestrian collisions. Our scanner has really saved our butt in pedestrian collisions and analysis by looking at smaller data that gets blown away or moved, kicked, ran over. again, another dynamic situation where we need to catch a lot of data really fast with great detail, and this scanner has been a lifesaver in those instances. We always recommend to start from a centralized location where you can collect most of the data from one position and take the opportunity to capture critical data from one position, especially your short-lived evidence first. Since diagrams are an integral part of any reconstruction analysis, remember that you're going to have to decide how or what it is that you need from your scan when you get into your diagram. You have to be able to see it. Again, the single position may get what you need, it may not. In this case, where we see vehicle tire marks leading off the roadway, a single position scan certainly can document these tire marks, but may not be adequate to document the off-road. So multiple positions may be required there. I'm going to show you a real crash and give you some examples of time savings from single position scans. So what we've done, we haven't embellished anything here. These are time stamps from the photographs. This was a two-vehicle collision crash, happened at arrival at 11:04 a.m. So keeping in mind that while the scanner is working, I'm taking pictures, I'm gathering other information, so I'm not wasting any time whatsoever. The scan results in what you see here, where we can see both vehicles at their final rest position relative to roadway lines, utility poles, traffic signals. And while we have a lot of noise in this scan, it's still very usable because we can see axles, bumpers, tail lights. We have all kinds of information to place these vehicles back at the scene. Now remember, 11:04 was the arrival. By 11:15, one of the vehicles is now gone. The scanner was able to capture the position of both vehicles without interrupting or holding up the process of cleaning up the scene and opening up the traffic. By 11:36, the second vehicle is loaded. And by 11:37, that scene is clear and almost ready for traffic to release. So 33 minutes from the time of the arrival, the evidence from that crash is completely gone. But by using the scanner and the crash zone CZ point cloud, I'm able to create a line drawing from a combination of the scan and collecting simple points to locate the final rest of the vehicles. So by 12:15, I have a diagram that's complete enough for turning in on a crash report. I have a total time here of about an hour and 11 minutes, roughly, from the time of arrival to the time the diagram's complete, which is what makes the scanning more efficient than just even trying to draw a diagram by hand, for example. Two-position scans. In this case, this was a very high-speed, curvy roadway. I didn't want to get out in the roadway, so I've set the scanner up on the opposite side of the diagram. It can still see all the paint marks. So I go from one side of the road, move to the other side, and I can see all of the paint marks, identifying the final rest of the vehicles, the gouges, etc. And using a simple 2D diagram, I can illustrate where all of those markings are. Do this quickly, efficiently, and without impeding the flow of traffic and without endangering myself or the equipment. We want to centralize anytime we get on scene. And by centralize, I mean place the scanner where you can see the most from one position. Capture all the data you can from one position, and then start moving around the perimeter. This will allow you to capture the most amount of data in the least amount of time, and if something goes wrong, as it always does, either a battery dies or you have equipment failure or lighting conditions or other emergencies that change your timing, you've captured as much as you can when you first get there. Downloading on scene, we are really proponents of getting this done so we make sure that we have all the data before we leave the scene. I've talked to you a little bit already about interior scans and single positions in those interior scans. Now I'll show you real quickly. A centralized location capturing data from a crash and moving the scanner without any targets. We're capturing all of the information that we need to create a line drawing. And as we look at these images, after the crash scene is clean, within 30 minutes we were able to capture everything we needed. And now we don't have to worry about going back and remeasuring paint marks. Everything is complete. Accuracy confirmation is a very important part of our scanning process, so we are always using some kind of scale when possible to prove the accuracy that the laser in fact was working correctly. Remember, the elevation is always better. Shooting above your targets or above your scene is always beneficial, as you will avoid capturing people in cars. Now, I want to thank Eugene for what you're about to see. Eugene introduced me to the proper methods to use Cloud Compare, another software that was free of charge. So I was able now to scan roadways. I've got a photo showing final rest of a couple of cars. This is the scan of the roadway, and in the distance you can see some of the orange paint marks identifying the final rest of these vehicles. Scanning the vehicles at the tow yard and then using Cloud Compare, I'm able to place those vehicles back at the scene with a reasonable degree of accuracy for the analysis. Again, another crash involving a commercial vehicle and a passenger car. Scanning those separately at a tow yard and then placing those vehicles at a scene, both at impact and final rest. Now we can analyze the crash properly, determining speeds, distance, time and distance, and visibility. I want to thank all of you for time and taking to listen to me. And if anybody needs to contact me or would ever have any questions in the future, my contact information is here. Eugene, again, I want to thank you for allowing me to give me the opportunity to be a part of this webinar.
Okay, thanks. Hey, Bobby, actually just a couple of questions that were, let me switch back to the main view here because I know some people had a couple of questions about accuracy. One of them was about using the data in court. And have you had any problems presenting the scan data in court?
No, to date, we haven't experienced any significant issues getting the scan data in court. However, what I anticipate is that as we move further into the scanning technology, that people will develop questions that will need to be answered. But so far, we've been really lucky. We've got everything in that we have published.
Another question is about the final courtroom product. Is it a plan drawing? Is it just an overhead sketch? Do you actually provide like a 3D environment, or what is it that you typically provide the courts?
Typically, I provide the courts a plan drawing. We will take images from the 3D, but we don't bring the computer in, for example, to illustrate out of scene or Cloud Compare. We try to avoid that just simply because of the complications of technology often failing. So we keep it as simple as we can, and we've had great success following that procedure.
Okay, just one last thing. So for those of you who are interested in Cloud Compare, there's a question about where you can get some more information. I don't remember the actual web page. Actually, maybe I can bring it up on my screen here if you give me a moment. And I don't know, this is going to be broadcast, but it's, all right. So it's actually www.danielgm.net and then /cc. And I just want to make sure that, can you guys see that on my screen? I think you can. Okay, good. So actually what I'll do is I'm going to copy this and I'm going to paste this into the, just the chat window here so everybody has that. So that's one place where you can get some information. There are some tutorials, some video tutorials on there, which you can follow along and give you some basics on Cloud Compare. Okay, so right now what we're going to do is we're going to switch over to David Dustin here. I know we're running a little bit behind, but David's actual presentation wasn't going to be as long. So I'm going to unplug the headset here and pass this over to David. So just give us a second, and Robert, if you could switch over to make David the presenter.
Should just be a few minutes here. We're just clearing up some audio issues with David Dustin. Sorry about that, everyone. Just give us another minute.
attendees are muted.
Hey folks, can you guys hear me? This is Eugene. Okay, you guys can hear me. Okay, we're going to switch this over to David.
Hello everyone, sorry for the audio problems. Surprisingly, Eugene, Bobby, and I are all sitting in the same room, and yet we're having some audio connection issues. My presentation is going to be very short. I wanted to take the opportunity. This is a case I recently worked on. This was a vehicular homicide case. And so what I have shown here, I have the point clouds actually placed at the position of final rest. And I was working with a reconstructionist on this particular case. So he gave me a drawing of what his opinion was as to the wreck and how it occurred and the timing, etc. And so I went about and then I animated the paths of the vehicles to coincide with his accident reconstruction. And you see down here in the corner, I actually have the impact speeds of the vehicles and then their rotation and as they slide into the positions of final rest. And the recon was actually, the reconstructionist was directing my efforts as far as the vehicle paths as well as the depth of the impact. So I can't take any credit or blame for the vehicle motion other than, so we're doing this in 3D Studio Max, which is our preferred method of application for these. And we're using the plugin Clouds to Max to import the point cloud into the environment. And you can do the same thing whether it be with Eris 360, you could do it with Edge FX, you could do it with Crash Zone to be able to import vehicles as well as point clouds and drawings. So this isn't just a plug for 3D Studio Max, it just happens to be the one I chose to do this. So of interest, at least in this particular case, was the point of impact and then the points of final rest. And so we can turn off the vehicles here and we can bring the actual point clouds of the wrecked vehicles and showing them in position. Now, so we scanned both vehicles were held at an impound yard, and we scanned them together, and then we separated the vehicles. We were using a Faro scanner, but so we separated the vehicles into different project files, exported them, and then imported them as a separate file so that we could position it. We could have essentially shown them at the point of impact as well. We could actually animate the point cloud of the wrecked vehicle if we wanted to show that as well. It was just thought that this was a cleaner method of displaying it, just showing them at the point of final rest as opposed to animating a wrecked vehicle. The attorneys and accident reconstructionists thought it would be too confusing for people to view it otherwise. So in this particular case, the point of contention was who had crossed the center line. This person in the red vehicle was charged with crossing the center line. This was our client, and the reconstructionists firmly believed that it was actually the other vehicle that had crossed the center line and that our client should be exonerated. So as you can see, we show the vehicles along their paths, we show them impacting. We could have shown deformation as well, but we thought that that was not really required because we had the final crushed vehicles anyway. It would have added to the level of complexity for the project when, in essence, we already had it. So, and we do quite a few cases like this. I've got another one that's almost identical to this, a vehicle crossing center line, and so then we animate the vehicles directly over the drawing provided by the accident reconstructions. And typically it works very well. To maybe head off some other questions, I know Bobby was asked if he had ever been asked to prove the accuracy of his scans. I have not either. Typically when I am deposed or any kind of testimony, I am the one telling them what the accuracy is. At least in the venues that I am in, the attorneys typically are not, they don't know the right questions to ask yet. And I would agree with Bobby that at some point that's going to change. As scanners continue to proliferate, we are going to see more and more of those prepared attorneys on both sides that are going to be able to ask those tough questions. The way that we answer those is not only do we take site measurements of major objects, but we will also place scales in the scans so that someone can easily take their own measurements should they choose to. And typically we try to use an evenly incremented device, whether it be a 5-foot scale or a 4-foot scale, something that even if the image quality is somewhat questionable, you can quickly select the ends of the object to verify your measurements. So that's really all I have on this. I know we are over on time. I knew it was going to be short, so I didn't consume a lot of time with preparation. So I'll turn it back over to Eugene.
Okay, everyone. Well, is there any last-minute questions for David Dustin? Because we could take a question or two before we sign off here. Okay, I'm not seeing anything coming through at the moment. So, all right, well, listen, I want to thank everybody for their attendance. Look for another webinar probably in the next few months. And I appreciate everybody's attendance. And, yeah, there will be a recording of this. It will be posted on our YouTube page in a couple of days. And I believe Robert from our office has sent or he's going to be sending a link at some time on here. Robert, do you have that handy? I'm not sure if you can post it in here.
Well, if I posted up higher where you can log into the website and go to the webinar archive. It's iafsm.org/webinar_members. That's the online webinar archive. It'll be posted on there, and I'll email everyone when it gets posted.
Okay, that's a good point. Yeah, so instead of going to the YouTube page, you can find the links on the FSM website. Okay, everyone, I think that's it for now. I'll just... I think that was directed at Bobby. I think, or was for Dave too. Actually, I think that was from Dominic? Okay, so one last question before we go. There was a question about registration accuracy. Dominic, if you're there, could you type in the chat window, who was that directed to? Was that for Dave Foster or was that for Bobby Jones?
I've seen it here, Eugene. I can see it.
Okay, that was to Dave.
Yeah.
Any idea on that, Dave, with respect to registration accuracy? I'm not sure if you've ever done an overall compared to a total station or some other hand measurements or something like that.
We are looking at increasing the authenticity of calibration, for want of a better term, against probably TPS. But generally, the accuracies that we're finding are around about 3 to 4 millimeters, broadly speaking, and sometimes it might be a little bit more, but I mean, at around 3 millimeters, I don't think we're going to be really upset at all. And as Jake's put on there, you know, 1 centimetre. We're talking fractions.
Yeah.
It's barely registerable. The one we did in Vienna, there was it was 20 odd scans that we put round a building, and it was about 3.5 mil accuracy by the time we closed the survey up, coming back round to the start. So I think we're fairly happy with that. In fact,
Yeah, I think
happy.
Yeah, I think if we're talking about a centimetre over 200 meters, I think for most reconstruction work that's quite good. Yeah. Okay. All right, everyone. I think we'll sign off from here because we're well over time, and appreciate it. Have a great week, and hopefully we'll see you on the next webinar. All right. Thanks, Dave. Thanks, Bobby, and thanks, Dave.
Cheers, Eugene. Thank you.
Bye-bye.